Hello YouTube, Rugved here from Coding Geeks. Today we'll be learning about an algorithm called merge sort, which is a very famous algorithm for sorting. Also, we will be coding it using recursion, so make sure you understand the basics of recursion before proceeding. So, merge sort is an algorithm that uses the divide, conquer, and combine method, in which divide means partitioning the array to be sorted into two subarrays of exactly half its size. Conquer means sorting the subarrays recursively using merge sort, and combine means merging the two sorted subarrays of half size to produce the sorted array of n elements. Also, merge sort has a time complexity of n log n and space complexity of n. So what merge sort does is it keeps dividing our unsorted array until we have singular elements, and while putting them back, it combines all adjacent arrays in a sorted manner. So for our explanation, we will be taking this unsorted array which starts with 39, 9, 81, and so on and so forth. So what we start by doing is we split this right at the middle into two subarrays, like the first four element and the next four. We keep doing it the same thing until we have singular elements, as you can see what has happened here. And then this is the division part of the array. And once we have divided all these elements, while putting them back together, we check which element is smaller and put it first, and then put them in ascending order. For example, as you see here, 9 is lesser than 39, hence it is put first, and 39 is put as the second element. Same here, same here, and same here. And then once we have arrays of length 2, 9, 13, and 45, and 81, we check which is the smallest element in all four of these. 9 is the smallest element, we put that first, then 39, then 45, and 81. Same thing here, since 18 is the smallest, we put that first, 27, 72, and 90. This operation becomes easier because the arrays are sorted, hence we have to just see the first element or the nth element on which our pointer is, which we'll get into very soon. And now, merge sort algorithm focuses on two main concepts to improve its performance. A smaller list takes fewer steps and thus less time to sort than a larger list. As you can see, 9, 13, and 45 and 81 take smaller time to sort than this large list. And also, as the number of steps are relatively less, thus less time is needed to create a sorted list from two sorted lists rather than creating it using two unsorted lists. As we can see here, we just have to check from the start and keep going ahead while comparing the respective elements and deciding which element to put first. For example, here we just have to compare 9 and 18 instead of always finding the minimum element and comparing them and then deciding which element to put in our final array. As you can see, once we are done with 9 and 18, to find 27th, we just have to look at the second element instead of finding the minimum element in this entire array. And as you can see, we get a sorted result here. And that is about it for the concept of merge sort. Now let's get into coding it. As always, some input output code I've written to follow along with our example. This is C++, but since the logic remains the same, you can follow along with any language of your choice. Vector is basically a dynamic array in C++, which will store our unsorted array. And what this range-based for loop does is it gets the sorted result from the merge sort function and prints the vector. So for creating our merge sort function, what will do is it will create a vector and return, which will be sorted, of course. And also its argument will be input array. This is by the way recursive function. So we need to start defining a base case where the function will exit. And in our example, the base case would be to stop at when the elements are singular, because since a single length array is always sorted because there is no other element to compare with. So we will stop when the length of our array is 1. So for that, what I'll do here is I'll find the size of my array size, and also if my n is less than or equal to 1, the size of my array, I will just return the array itself. Once I'm done with this, now we are proceeding to the divide part of merge sort, which is merge sorting, which is dividing our array into two parts from the middle, as you can see here. So for that, what I'm going to do is I'll create two arrays or vectors in C++. What they will store is array from the beginning. Basically, what this syntax does is in C++, This creates a vector and copies elements when you define a range for it. And in this case, our range is from the start of our input array to the middle of our input array. And as you can see, this is our first array. Let's name this array 1. This is the first half of our input array. And in the same way, if we go to define the second half, what I'll do is I'll start from the middle element and work my way up to the last element. This end. Once this is done, I have successfully divided the array into two parts. And now we will be proceeding to the divide part of our function. So what I'll do is I'll create an array. Actually, I already have an array 1. What I'll do is array 1 before was just the unsorted half of our input array. Now after merge sort returns the sorted half, it will store the same thing. But the thing is, instead of defining a new array, I'm just reusing my old array because I don't want to waste any more memory. So same for array 2. And once this is done, I'll just return the merged array of both of them. And now we're going to be creating this merged function which merges all these both arrays. And let me tell you, these both arrays will be sorted as we'll see in the merged function, and the recursion will start making sense. So for the merged function, we will obviously return a vector here and the merged function, and our inputs arguments will be the two arrays, and array 1 and vector another array. The second array will be and array 2. Once this is done, this is corrected. Now what we'll be going to do is we'll create a final array which will accommodate the sorted combination of both of these arrays, and then I'll also create counters or indexes which will index the arrays and the elements. Okay, once this is done, now we will be creating the main merge array loop which will merge both of these arrays together in a sorted manner, that too. So let's look at that example here. What we have to do here is, since we have our index at 0, we'll be starting from the start, and these arrays are of different length, and you will see how to combine arrays of different length too. So as you can see in our example here, what this does is, in this example, in this case, how it merges them is it takes the smallest out of these 4 elements, puts it there, then takes the next smallest element and puts it there, and keeps going on until we're out of elements. Same way here, an example, the smallest element between 20 and 15 would be 15. So we'll put 15 here, and then the pointer will go ahead to 22. And since both of these arrays are sorted, this makes it really easier for us to find the next smallest element in that array. Hence, after this, 20 will be the smallest, then 22, and then these counters would be ahead. Then it would be 31, sorry, 30, 31, 40, 45, 50, 56. So once I've done this, my end pointer would be somewhere around here, and for this array it would be 62. So as you can see here, 60 is smaller, hence we'll put 60, and this array is out of bounds. So what we do in this case is we also have to check the sizes of these arrays, and once if one array is out of bounds, we just put the elements of the larger array in length. So all we'll do is put 62 and 78 here, because since this array is larger, it does not have anything to compare with. And also these elements are larger than the largest element of this first array, which is 60. So we'll do this. Now to put our explanation into code perspective, what I'm going to do is create a while loop, which will compare the indexes with the respective sizes of my array. Or I'll denote the significance of for in a bit. Second, 1, 2. So the reason I put or here is because I want my loop to run until both of my elements are in this final array. Both of these arrays elements are in the final array. As you can see here, even if the sizes are different, I need to include both, not just size of the one array, because in that case, if I put an and here, it would just include till 56, ignoring the 62 and 78 here. That is why I put an OR here. And now what I'm going to do is the very first condition I'll define here is if array1's dot index is, or I'll just copy this entire condition. We get back to the condition, and I'll put an AND. So what I'm doing basically is in the very first condition, I'm checking if my counters are inside, both of my counters are inside their loop, inside their list. For example, in this case, as you can see, if my pointer was at 15 and this pointer was at 20, and we can see both of my pointers slash counters slash indexes are inside my list. So I just have to compare both of these elements and see which is smaller and put that in the final array. So that is exactly what I'm going to do inside this if. I'll check if my array1 dot index, since this is the iterator, if it is lesser than the array2's index, the element at index location, as you can see here, 20 and 15 as an example here. And what I'm going to do is, if this condition is true, if the first array's nth element is lesser than this array's nth element, what I'll do is I'll append that element, I'll add that element into my final array, which will be the sorted result. It's a sorted combination of both of these. So array1 dot x. And once I'm done with this, I'll have to increment the counter. That is very important since you don't want an infinite loop. And in the same way, what I'm going to do else, if this is smaller than this, I'll do exactly the opposite of it. I'll push back the second array's element and also increment the array to index counter. So after this is done, our first base condition is done. Now for the second condition, as we saw if my pointer is somewhere around here, 178 as we had before, and it points here. Now as you can see, the first loop is out of bounds while the second loop is still running. So we know that the first loop is out of bounds, and hence our condition here will fail because this will come out to be false and this will come out to be true. But since this is an AND operator, the condition will go false and it will skip to the next condition. In this case will be our else if. And since our first loop is out of bounds, we will check if our second loop is still in. Dot index is less than array2 dot size. If it is like that, what I'll do is I'll just keep adding elements from this array to the end until this array also runs out finally, and it will run out. So here what I'll do is I'll do final dot pushback array2 x. So my insert button just drop down here. And then array2 dot index plus plus, which will increment my array2 index counter. And in the same way, there will also be our last case where our first loop may be, our first list may be larger. So if I have something like this, so as you can see, even if this pointer is out of bounds, this is still running and my first list is larger this time. So I'll do the same for the first list which I did for the second. I'll check if my first list is larger, as in if it is still running, because as you can see here, this is an AND condition. Either of these can fail. So we need to figure out which of these has failed here. So this is for the second. If the second is larger in length than the second list, this is for the first list. If it is larger in length, push back. Next, and once I'm done with this, index plus plus, this will increment my counter. Yeah, and as you can see, we have completed our loop and we have seen all the conditions, all the possible conditions that can arise in our merging process. And once we have merged this together, what I'm going to do is I'm just going to return my final array, the merged array, which contains elements of both of these input arrays in a sorted manner. So now to take a live example of this, what I'll do is I'll run through my little list here, see how this array works. So in our example, firstly, what I'll do is array. Now we know that the array 1's size is 3 and array 2's size is 2. And we know that both of the indexes are at 0, so this loop will start executing. Now since both of these counters are inside their respective arrays, this condition will get executed. So if array 1, so this condition will go to this condition. If array1 dot array index is less than array2, basically we're comparing 1 and 2 here. And since this condition is true, this block gets executed. So our little final array here will have 1 in its input. And since we are incrementing array1 dot index, this will get to the next element of this first array. And then after we come out of this while loop, these are all else ifs, so these just get skipped and the next iteration comes into play. Now in the next iteration, it will again go inside this nested if and inside this. Now since this element is bigger than the second array's element, so the second array's element will be smaller and hence this else part will be executed. Array2 dot array2 index. Now we push 2 inside this since 2 is smaller, and also increment array2 dot index. This will become 3. And now after again coming back to our loop here, we will again compare 4 and 3. Since 3 is smaller, 3 will be put and this will go out of bounds. Now in our next iteration, where our pointer is out of bounds for the second array, but it is still in for the first array, this entire if block will go null because the second array's index is not anymore less than the second array's size and it is out of bounds. Hence this AND will come out as false and we'll move on to the next condition. Is this else? It is this, sorry, since it is the first array is larger in size. So this will simply push back our current element, which is 4, and just increment the counter. Again going to the next iteration, it will again jump back to this since then the second array is anyways gone. And again it will push back 5 here, and we have 1, 2, 3, 4, 5, and this will run to the end. And now as you can see, we have a sorted list here, and we'll just return this sorted list, right? And now as you can see here in a recursive function, this keeps dividing and merge sorting our array all the way until it gets to single elements. And this array also works for single elements since they will just run this loop once and then one of these whichever element is larger. If you think about it, you can maybe do some paperwork to see if it works, and it will. So if I try to run this, I already have a sorted list. As you can see here, 1, 3, 2, 5, 4, and I have 1, 2, 3, 4, 5. And finally, we have a sorted result. To take another example, let us just take the example from our little list here. If I copy this, this is exactly how my algorithm will work recursively. It will keep dividing, and then once it gets to singular elements, it will start sorting them, merging them, and it will start returning from the merged function. The merge function comes into play, which is here. Our little merge function comes into play and keeps merging all these sub arrays. Here, let me put commas. Now, once I put commas here, I'll try executing this. And let us compare this with the final result. Let me just check one thing. As you can see here, we have accidentally copied 2 lines. So let's just remove that. Okay. The merge sort still works for equal elements because they will be in the same, they will be adjacent, which I will just show in a bit. As you can see here, we have 9, 18, 27, 39, 45, 72, and 81, which is the same as this, which we forgot the 90, but that doesn't matter because we just wanted to show a proof of concept. And yeah, our code works and we have successfully implemented merge sort. In conclusion, merge sort is a very good algorithm for sorting if you don't have memory restrictions, since due to its nature, it guarantees it will run in n log n time as opposed to algorithms like quicksort, which may take longer time in some cases. Also, merge sort has a space complexity of n because we create a new array in the merged function and return it, as you can see here. So in cases where you have ample space and want a quick and reliable algorithm, merge sort is the way to go. And that is about it for this video. I hope you enjoyed it, guys. Please like, comment, share, and subscribe for more content and the YouTube algorithm. This was Rugved from Coding Geeks, and I will see you next time.